All right, sharing the screen. I'm going to minimize you guys. If you can't see this, let me know, but I'm assuming we can see this. So yes, thank you, Shamil. This is true. My name is Bethany Sump, and as of 2 days ago, I am a graduate of the IBIS program in molecular biosciences. And today I'm going to talk to you guys about my teaching as research project, which was investigating the student benefits to implementing mutation-based learning in a biology laboratory setting. So just to start with a little bit of research context for you guys, I was the instructor of record this past quarter for Biosci 222. That's an investigative biology laboratory. So this is a molecular biology lab on signaling pathways, what we were studying. This is the third quarter of a year-long laboratory series. So I've had the same 40 to 50 students for about that long. We meet for 4 hours once a week. This is with the School of Professional Studies. And I had 32 participants in this particular study. The issue I wanted to address is what I had seen in previous quarters, which is that students were not able to understand the importance of individual steps in standard protocols that we use in molecular biology labs. And therefore, they were unable to make predictions on what happens if certain steps are changed in their protocol. And they were unable to make corrections to save their experiments if they messed up, which if any of you have been in labs before, you know that happens quite a bit. And so I really wanted to address this. So I looked into the literature. And here are just some really basic takeaways from a easy literature review. Basically, you find that student performance is really linked to teaching that supports autonomy. So that's really what you want to improve with the students. We find that the need for autonomy is essential for facilitating natural growth, integration, and personal well-being. If you want students to evaluate themselves, to plan, to study their own activities, to think about themselves as learners, you're really encouraged to provide help, instruction, and expectations in really autonomy supportive ways. So how can you do that in a laboratory-based setting? What I did is I read the paper in 2017 by Jinlu Wu, which was about mutation-based learning techniques. So this is a technique you can use in laboratory settings. So I read this paper and it's absolutely wonderful, and I tweaked it to see if I could implement it in my laboratory settings as well. So how do you run a mutation-based learning laboratory? Here are the basics of how to do it. The first step is you have your student teams perform a standard laboratory protocol, and whatever you have chosen to be their easy protocol. And the second step, you would then have those teams design a mutated protocol. So it's that same protocol, but then they can add, subtract, or mutate any one step within that protocol. So they're creating one variable. In the third step, then you have your student teams discuss and agree upon a hypothesis for what is going to happen because of that one mutation that they're making in a standard protocol. And step 4 is to have the students perform the standard protocol and the mutated protocol side by side and make comparisons of the outcomes to see if their hypothesis lined up with what they thought was going to happen. So here is the protocol that we used. So for you non-biologists out there, we use the polymerase chain reaction. PCR is a very standard assay used in molecular biology all of the time. So the point of PCR is to create mass amounts of specific segments of DNA. And this is a really easy assay to use. So all you have to do is take these reagents, purified water, template DNA, primers, dNTPs, which are the building blocks of DNA, and attack polymerase, and you put those all in a tube, then you put them into a machine, and the machine will take them through these 3 steps. So in step 1, it's 94 degrees, which is the initial denaturation of your DNA. In step 2, you will again denature for a short amount of time, then it'll cool down to an annealing step and heat back up to an extension step. This repeats 30 to 35 times. And in the third step, there's a final extension, and then it cools to 4 degrees where it's kept. So this is a very standard assay that I had them do in week 1. Then they can make mutations. So for some examples of mutations that were done by my teams, I had one team decide to put 5 times as much template DNA as was originally called for. I had one team double the amount of primers that were used. I had one team only use half the amount of taq-DNA polymerase. I had one team decide to make unequal mixtures of dNTPs. Usually that's an equal mixture, and they decided to make it a different ratio. I had a team decide to do a shorter denaturation step, and I had a team decide to do a longer annealing time. So those are some examples of how they decided within their teams to mutate this standard protocol. So this led me to, I really got to ask 2 big research questions about this. So number 1 was, does the chance for students to make decisions about altering a known protocol cause an increase in the student's ability to make predictions about various theoretical changes throughout a molecular biology lab course. And question 2 is, do students report that the ability to make decisions about altering a known protocol cause an increase in their ability to evaluate and suggest improvements to an investigation and make sound scientific predictions through a molecular biology lab course? So it's a lot of words, but an easy way to think about these two questions is, 1, does their actual knowledge increase? Are they better at making hypotheses for when things go wrong in lab? And 2 is, do they feel like, are they self-reporting that their ability is getting better? So are they getting better, and do they feel like they're getting better, were the 2 questions that I was asking. So how do you ask those questions? Question 1, are they actually getting better? My research tool was quizzes. So I did a baseline and final quiz before and after implementation of the mutation-based learning. So in this quiz, the students were given the PCR protocol so they could reference that throughout the quiz. They were told to make predictions about a hypothetical mistake in a protocol and explain why they made that prediction. So I graded all of those. They were given +1 for answers that were biologically plausible and could have been a correct outcome for the mistake that was being made, and +0 for any answers that were not biologically plausible. So they were given 5 questions per quiz. It was 10 different questions. They were never repeated, but they were all about the same difficulty level. So their total points for each quiz could have been 5 if they got all 5 correct. The second question, do they think they're getting better? I use surveys for this, both a baseline and a final survey. So they were given a survey measured on a Likert scale to gauge their confidence with protocols of some different questions I will tell you about in a minute. And then at the end of the final survey, they were invited to submit open-ended comments as well. So how did the implementation happen? In week 1 of lab, they were given introduction to the ideas of mutation-based learning, and they were also given their baseline survey and quiz. In week 2, this was the first time performing the standard PCR protocol. In week 3, they worked with their group to develop a design. So what were they going to mutate? What was their hypothesis for that mutation? They submitted that to me and had discussions with me about it. In week 4 is when they did both protocols side by side, both the standard and their mutated protocol. And in week 5, I gave them their final quiz and survey. So looking at research question 1, what were some outcomes I actually saw from this? So before implementation, their baseline grade, average of the class was a 2.375. Again, out of 5 was the possible highest score they could have made. And then after, so in week 5, after all my post-MBL teaching, we got an average score of 3.5 out of 5. So that is a definite increase in their actual ability to make predictions about mistakes in protocols after this MBL intervention. But I really wanted to ask, was this individual students, a few getting a lot better, or was it the entire class just getting a little bit better, and that's why we're seeing the increase? So I took the same information and broke it up. So in the x-axis down here, what you're seeing is their overall change in quiz grade. So it's their final grade, so out of 5, and then minus their baseline grade, again out of 5, and the number of students is on the y-axis. So a 0 here means they got the same grade on their final and their baseline. Quit. So we had a few students who actually did a little bit worse on the final, but you can see a majority of the students did a little bit better, got either 1 higher or 2 higher, a couple getting 4 points higher on the other grade. But overall, so there are a few outlier students, but overall it is a whole shift of the class just getting a little bit better over time. So for the second question, do the students self-report that they think they are getting better? I asked 6 different Likert scale questions. So first was, I asked them, I am confident in my ability to predict the outcomes if any step is missed or messed up in a protocol. And they were able to say not at all, a little bit, somewhat, mostly, or completely. And again, this is pre-intervention and this is post-intervention down here. And as you can see, there is a shift, quite a big shift in their ability to predict outcomes and what they feel their ability to predict outcomes is over time. So this is a definite increase in their ability and their confidence, I should say. And then they're also asking, oh, I don't like having this thing here. Let me move that. I'm confident in my ability to fix an experiment if mistakes are made without asking the instructor for help. Again, we are seeing an increase in ability going up here. I asked them to rate their confidence in the ability to follow a written protocol, and we do see a small shift up the Likert scale here. Not huge, but there is a definite shift. And then I'm confident in my ability to understand the importance for each individual step in a protocol. Again, not a huge shift, but there is a few more students choosing mostly instead of somewhat, so there is a shift up there. Then we had, I'm confident in my ability to identify changes that could be made in a protocol to improve overall outcomes in that protocol. Again, not a huge change, but there are more students that are now choosing somewhat over changing a little bit or not at all. So that is an increase in confidence there. Then the last question was, I'm confident in my ability to make accurate predictions about the outcomes of experiments. And again, not a huge shift, but there is a definite shift of students now saying that they are mostly confident in their new abilities. So that is all great. And in the last survey I gave them, their final survey, I asked 2 additional questions. This was to break up the MBL process into the 2 main components that I felt were important. The first one was that asked them to rate that I felt the conversations that my group had with each other was helpful in thinking about protocols. And you can see the grand majority of students said it was very helpful, or yes, a little bit helpful. And then I also broke it up into, I felt that doing the actual experiment, so not just the conversation, but the actual experiment of completing the standard protocol next to your mutagenesis protocol was really helpful in thinking about protocols. And we have 44% of the students saying, yes, it was very helpful, 31% saying, yes, it was a little bit helpful. Although there is a few students here, 9%, who didn't think the actual experimentation was helpful. So I also allowed them to give me some open-ended feedback, and it was mostly very, very positive. So we have some things like, overall, I thought it personally helped me truly think about each step of the protocol. Otherwise, I tend to blindly follow. It was a very time-consuming process, but it's helpful in better understanding PCRs, how to engage with protocols. The discussion was very helpful for collaborative learners in particular. Nice opportunity to discuss it in theory as opposed to typically concrete discussions. We have another student saying, I liked that we had the opportunity to modify the experiments and see if actual results support our expectations, think about rationale. We had a few students who were confused. So we have one here that says a little bit confusing when it was brought up in the beginning, because the whole lab in general was a lot of information right off the bat, which is totally fair. This was a 8-week class, and I showed you I was doing this in the very beginning, and there was a lot of information about the actual lab and not this MBL stuff at the very beginning as well. So throwing this on top of what I was already teaching them was a little confusing. So absolutely fair feedback from them. So my overall conclusions and takeaway from this process was that this was definitely overall beneficial for the students. This was a good thing. Progress was made, and the discussions I had with students as I went around to discuss their hypotheses and how they wanted to mutagenize their experiments were amazing. That was my absolute favorite part. It was major happy teacher moments. I had not a single group choose what I would say would be an easy change. It would be super easy to say, like, we're not going to add polymerase at all. And of course, that's going to mean there is no DNA at the end. So just like very easy outcomes. All of them chose outcomes where it was like, maybe one thing will happen to the other. And then they had really great discussions with me and with their group about it. And it was just absolutely wonderful. I loved it. Now, the actual implementation of this was very difficult for me, and it was confusing for the students. I had to write and prepare 10 different protocols the week that we did this, and that was so much work. So I don't really recommend ever doing that again. So how do I find a middle ground about all this? And I would say if you have a large number of students, so I had about 40 students I was doing this for, only have the hypotheses and discussions. That was very useful for everyone, and it can clearly be done very quick and easily. If you have a small number of students, you can actually do the experimentation. That is important for some of them to see the results and these differences. But I have some ideas to make that a little easier on myself and on them later on, but I probably would not ever do that with a big group again. And here are just some of my references. So now I'm going to stop sharing for a second and open it up for some questions.